Welcome to Competency 18, Part 2. In this video, we will discuss counterexamples. Okay, we're going to discuss counterexamples, which is any example that is specific, that it can be used to disprove a general statement, hypothesis, or rule. Somebody makes a statement, there's some theorem out there, and there's that one counter or several counterexamples. Those things that say, hey, I followed your rule, but that's not the conclusion I came to. Okay, so number one, consider the following three statements. The number 4 divides 16. The number 4 divides 36. The number 96 is divided by 4. A claim is made that any two-digit number with the digit of 6 in the ones place is divisible by 4. Which item below is a counterexample? Okay, well, we have our options, and then we have D. D says none of these above. I never trust none of these or all of these. I'm always very hesitant to select those. Okay, so what do? Just put it in the calculator. Okay, 56 divided by 4. That one works. 76 divided by 4. That one works. 86 divided by 4. Nope, that does not work. See, I knew D wouldn't be an option, but there would be that one time on a test that it would be an option. That'd be just my luck. Okay, we'll move up. Right. This is an interesting statement. Number 2 says all the odd numbers are prime. Are they? All right. Select all the items below that are counterexamples. It says all items, so that's telling me there's more than one thing here I need to select. All right. Number 9. That's odd, but is it prime? No, 3 times 3 is 9. That is composite. So that's a counterexample. 21. I know 21's not odd because 3 times 7 is 21. It's odd. It's composite. It's a counterexample. Now we've come to C, which has number 2. 2 is prime, but it's even. So it's a different type of counterexample. And actually, that I know of, I believe that may be the only, it could be wrong, but I think it may be the only prime number that's even. But I would look that up if I were you. Okay, I may be remembering that incorrectly. Okay, 43. It's odd. Is it prime? Yeah, I don't think you can divide it by 13. No, 43. Try it. You can try even numbers and all. No, that is prime. So that's not a counterexample. So we actually have 1, 2, 3 answers to this. That I've seen on practice tests. So if you're having to take a practice test at your university, that may be just something simple that they put in there just to see if you can think it out, that you've got the logical reasoning to work through it. Okay, let's look at number 3. Consider the following 3 statements. Okay, this looks like they're dealing with like a triangle inequality or something like that. Okay. No, they're not triangles, but it is an inequality. Okay, 30. Okay, so let's go with this. They're saying that all of these angles, the 3 angles added together, are less than 90 degrees. Okay, let's give it a go. Let's just put them all 3 in the calculator. 30 plus 10 plus 15. Okay, that is less than 90. All right, so I'm going to say, yep. All right, now let's see, 35 plus 12 plus 28. Okay, I believe that. All right, and 39 plus 11 plus, I know this seems like a waste of time, but just double check. Okay, yeah. Now let's keep reading. A claim is made that the sum of the measures of three acute angles, yep, all of these are acute angles. All of these are acute. What is acute? What you see in front of you. Acute angles are angles that are less than 90 degrees. Okay, all of these less than 90, less than 90. Then you add them up, they're less than 90. Okay, acute angles is less than 90 degrees. Provide a counterexample. Ooh. So we need to take all four of these. We're going to do some adding again. All right, 40 plus 19 plus 27 equals 50 plus 15 plus 25. Ooh, that one equals 90. That's interesting. Okay. 30 plus 10 plus 35. 75. Okay. 20 plus 30 plus 15. Okay, so we have all four in there. You want to double check the numbers to see if you made a crazy mistake. And I'm a crazy lady, so I make crazy mistakes. Okay, there we go. All accounted for. Okay, let's see. The option A right here, 86 is less. Well, it looks like all of them, but this one, the second one, option B right there, it equals 90. Okay. Is that a counterexample? Yes, because the claim was that they are all less than. The fact that we found one thing equal qualifies for a counterexample. Number 4, consider the following three statements. A rectangle with length 12 and width 3 has a perimeter of 30 and an area of 36. A rectangle with a length of 15 and a width of 5 has a perimeter of 40 and an area of 75. A rectangle with a length of 32 and a width of 8 has a perimeter of 8 and an area of 256. All right. Well, you can see some patterns emerging there. Let's see what their hypothesis is, their claim. A claim is made that for any rectangle, the numerical value of the perimeter is less than, the value of the area. So they're saying that P is less than A. Okay, all right, I can see that. Which item below is not a counterexample? Well, you just got to put this in the calculator and come to a conclusion. Do we have P less than A? All right, which one is not a counterexample? Okay. All right, the first one has all the sides are equal to 1. You can tell that that's a square. 1, 1. Okay. However, we need to think. It says any rectangle. Okay. Is a rectangle a square? Yes. But is a rectangle a square? No. But a square is a rectangle. So squares are rectangles, but rectangles can't be squares. It's not a two-way street, okay? So yeah. So we can look at this and this one. It's valid. Okay. So that being said, that's just properties of squares and rectangles. All squares are rectangles, but rectangles cannot be squares, but not all rectangles are squares. I'm sure you've heard that in school. Let's move on. Okay, so we have for the first one, if I can not, there it is. For the first one, we have P equals 4 and A equals 1. Okay, and it says not. So that one is, so we mark it out. This one says P equals, that is, oh, let's just put that in the calculator. 7 plus 7 plus 4 plus 4. I'm just doing them one at a time. Oops, back up, delete, enter. That's 22. So then A equals, well, that's 4 times 7, 28. Notice I'm not trying to do all this in my head. Okay, so now we have on C. Okay, oh, is that a counterexample? Not all are counterexamples. So what we're saying, ooh, this one, I think that may be it. The numerical value of the perimeter is, oh, this one, it satisfies. P equals 22 is less than 28, which equals the area. We found it. Well, let's go ahead and move on. Um, let's see. This one is P equals 6 plus 6. I know I'm doing this a long way. Forgive me, please. Okay. Oop. Okay, that's 18. Oh, yeah. And there's definitely a reason why I want to move on. Okay, now this one. All right. Because we need to discuss C. All right. So 3 times 6 is 18. Look at this. It says 18 equals 18. Is that a counterexample? Because they're equal, which is unique. And I wanted to show you this property in case you're asked a question very similar to it. So you could be asked, find the counterexample where the perimeter and area are equivalent. There you go. So that being said, this is a counterexample because he is not less than A. It doesn't give any less than or equal to condition. So no, that is actually also a counterexample. And then this is a square. So P equals 8, 2, 4, 6, 8. But area is 2 times 2 is 4. Okay. So this one is not a counter. I mean, this is also a counterexample. P is greater than 8. See, P is greater than A. And this one, P is equal to A. So, and on this one, I'll erase this. And P is, oops, sorry. That would make it true. Yeah. So we have greater than, less than, equal to, greater than. So yes, we are correct. Okay. Thank you so much for watching and putting up with my silliness. I really hope that you like these videos, that they're helping you, and they maybe just a little confidence or reminding you the small things that you've forgotten and the small things maybe that you could go ahead and just use on your calculator so you have a visual also. Okay, if you like us, give us a thumbs up and consider subscribing to our channel. Thank you.